So if you look at the history of deep learning and the machine learning community in general, there's always something new. Like every quarter, maybe every month, every week, there's always something new. There's always so much hype around everything, And this can be, very, very intimidating and confusing for people just getting started in this field. It feels overwhelming, It also feels like it's going too fast. So it's not actually moving all that fast. The hype is moving very fast, but if you look at the lower layers, the models are not evolving that fast. The architectures have been very stable. The training techniques have been very stable, and the core concepts, like the theory, has been extremely stable over the past few years. So my advice would be keep learning, keep adapting as well. Like there's always going to be something new to jump on. So be aware of that. Watch out for it, but don't follow the hype. Don't believe the hype.
Keras turns 10, and to commemorate the occasion, I'm sitting down with some of the original creators of Keras to talk about the creation of Keras, the journey that it's been on over the last 10 years, and we're really excited to have on François Chollet and Matt Watson. How are you guys doing today?
Great.
Doing good.
Thanks so much for having us.
Yeah. Before we get started, let's do a little bit of intros just for folks who might be new to you or new to Keras.
Yeah, sounds good. I'm Matt Watson. I'm a software engineer. Been working on Keras at Google for 5-ish years, I want to say, and I've been a Keras user, not quite since the very, very beginnings, but for 7 or 8 years.
And I'm François. So currently I'm running my own AI research startup. And before that, I was running the Keras team at Google. I was at Google for 9 years. So doing Keras since it started.
I guess going back all those years, it seems appropriate on this kind of occasion to talk a little bit about how you got started with Keras and the founding story, as it were, because I think many viewers and listeners probably aren't aware of that because they came into this industry well after it was founded, maybe, and just use it because of how popular and how easy to use it is.
I've been into neural networks and deep learning for quite some time. So before deep learning, before the rise of deep learning back in like 2013, I was already coding up neural networks. And at the start of 2014, like maybe January, February 2014, I started working on a kind of natural language processing research project. And it was this very simple chatbot where you could type in a query, like a question. Let's say, what's the height of Mount Everest? Or who's this Italian actor that starred in this and that movie? And you would get back a short answer snippet. So it was doing some version of what's currently known as RAG, retrieval augmented generation. And in the process of building this, I ended up working a lot with the Theano framework, which was basically the ancestor of TensorFlow. And so I kept building more and more tooling on top of Theano, and including a reusable LSTM implementation. And back then, like in 2014, there was a lot of nascent interest in RNNs and the LSTM model in particular. And so at the start of 2015, so about a year after I started working on quick answers, I was like, okay, maybe I should open source all this stuff. And that was the start of Keras. So I spent a few weeks packaging it up. So a few days after putting it on GitHub, I was like, okay, I've got a few hundred stars on GitHub. I should probably make this a real thing. So I registered the domain keras.io. I created a website, and it just grew from here.
This is actually my first touch with Keras was, I think it was like 2016 or 2017, and it was also LSTMs for generating text. I think it was Karpathy had done this blog post on the unreasonable effectiveness of RNN. So I made some very simple Keras library that was just for text generation on LSTMs, and then used Keras there, worked at Google and forgot about it all for a while.
The growth of Keras over this last decade has been so much has been thanks to the community, right? And the contributions of the community.
Yeah, I mean, I remember it was just when looking into LSTMs and wanted to play with it, it was one of the places that, actually had good documentation on how to do this stuff. And you could go in, and I remember, probably first time I technically talked with you was like reaching out to the Keras mailing list with some question on how to get LSTMs to work or something.
Okay.
I don't I'd have to find, I think it was like 2016 or 2017. So then when I joined Google and saw the Keras job chance, it was exciting to get to actually hop on the team and work on it.
Yeah, in general, many of the best Keras team members over the years have been people from the community. I think that's always true. It's always a good idea to recruit your users.
Keras has been so synonymous with machine learning and Python frameworks that it's become its own term, right? People know what it means, but I don't think everybody knows the origins of the name itself. How did you come up with the name Keras originally?
Right, so it's a bit of a complicated story. So Keras is a Greek word, and in Greek it means horn. So why horn for a machine learning framework? It sounds kind of weird. Well, to start with, the fact it's a Greek word is thematically consistent with, the original version of Keras was built on top of Theano. Theano, is also a Greek deity, so it makes sense. And the reason why I picked Keras as the name, it's actually a reference to a literary image that you find in the Odyssey. So in Greek literature, you have this idea that dreams are caused by spirits, by dream spirits that visit Earth and give you dreams. And there are two kinds of dream spirits, right? There's the false ones that give you a vision of the future that will not be realized. And there's the true dream spirits that give you a prophetic vision. They show you something that will come to pass. And the story is that the false dream spirits, they come to Earth through a gate, which is a gate of ivory, polished ivory. And the true dream spirits, they come to Earth through a gate of polished horn. And the reason why ivory and horn is because ivory in Greek kind of sounds like the word for deceive. And horn kind of sounds like the word for fulfill. And so the idea is that Keras, the gate of horn, is the portal, the gate through which a true vision of the future to be realized.
That is definitely more involved than I expected.
It's a fun story.
Yeah.
I like names derived from Greek concepts.
Turning back to the development of the Keras kind of landscape, like today we're at Keras version 3.0. And so since the founding to now, we've had many versions and many things have happened. Would love to hear about kind of the stages of those changes along the way and any meaningful memories you have of those times. I'm sure there were many.
The first version of Keras 0, was very centered around RNNs, and then very quickly added strong support for computer vision models, so coordinates. And initially there was just the sequential API. And the idea was to make deep learning models really easy to build, to configure, and to train, to make it as easy as scikit-learn, which was a very popular library at the time for machine learning, but
still is a very popular library.
Still extremely popular to this day. But at the time, it had no support for deep learning models. So it's like, okay, what if we have scikit-learn, but for deep learning? And unlike scikit-learn, it should also be very customizable. Like you should be able to specify your own models instead of relying on an array of pre-built models. So that was the core idea. And a few months later, so in November 2015, Google released TensorFlow. And TensorFlow was pretty much the Google version of Theano, and it had support for distributed training, which Theano did not. And so when I saw that, I was like, okay, TensorFlow looks like it's going to be a solid foundation to build on. So instantly I refactored Keras to become multi-framework. So to have support for Theano, which was already fairly mature and an existing user base, and this new thing, TensorFlow.
So Keras 1 was the first time where things were multi-backend, Theano or TensorFlow.
So the first multi-backend version was still Keras 0 dot something.
Cool.
Keras 1 was something like March 2016,
Cool.
maybe April 2016, and it was focused on greater flexibility. So this was the release of the functional API.
Okay, I was going to ask when functional
The functional API was like early 2016, and it was Keras 1. And many other features actually. So by then, the Keras API was already basically the modern Keras API. You had the sequential model, you had the functional model, you had callbacks. You could write your own callback classes, metric classes, classes, everything pretty much. Throughout 2016, it just got really popular, and by the end of 2016, more than half of the people who use TensorFlow in the world, and it was most of deep learning, most of machine learning at the time, were using it through Keras. So that's around the time that the TensorFlow leadership approached me because they saw I was at Google. So the funny story is I actually started Keras before joining Google, and then I joined Google because I wanted to do deep learning research. And so I was on the Google Photos team at the time at Google, building the model that does visual keyword search. Like you can type in some query and you get visual matches in your pictures. So this already existed back in 2015, and so I was working on that. I was doing research for these models, and so I was approached by Rajat at the time, who was the TensorFlow lead. It was like, okay, you're building this thing, it's popular. Do you want to join us? I was like, yeah, that sounds great. I would love to do this full time instead of just doing it as a side project. So in 2017, that was the age of Keras 2, and Keras 2 was this very TensorFlow-centric version. And at the time, there was a lot of pressure from TensorFlow leadership to kind of like drop multi-backend support, just make it TensorFlow. And that's how you ended up with Keras 2. And so 2018, a decision was made to embed effectively Keras into TensorFlow, which I think was not the best idea at the time, but there was just a lot of pressure to make it happen.
So when Keras 2 was folded into TensorFlow, was Keras no longer like basically a pip installable standalone library?
That's right. It was just part of TensorFlow.
For a period of time? Okay.
Yeah, that's right. There was still a Keras library, but that was the old Keras, effectively, the one you could see in Theano, and that was no longer in development. So all the new features were going into TF Keras, which was just a part of the TensorFlow code base. So I did my best to try to reverse these changes. And that's what led us to reuse the Keras repo on GitHub again. So it was still TF Keras, but with a standalone code base, and then eventually the rebirth of multi-backend Keras. And so it was of course a new landscape. So now instead of just having like Theano, TensorFlow, we had all the popular frameworks at the time. So of course TensorFlow, for backwards compatibility, and it's really had a huge user base, but also JAX. Which is very scalable, which has some really nice performance advantages, and PyTorch, which is very popular, especially in the research community. And in fact, we even have support for NumPy, so inference only, since it doesn't have autodiff, it doesn't have gradients. And more recently, we're still adding new backends. So we added OpenVINO from Intel, also inference only. And we also have an MLX backend that's under development by the community. And maybe in the future, we'll keep adding more backends. So Keras is completely independent again. In fact, you can run any Keras workflow without even installing TensorFlow. So that's great. And it's multi-backend again. And I'm really happy about that.
Were there any particular moments, whether in person or online, during some of these changes, like whether they were launches or announcements that you remember particularly fondly?
A couple ones I remember. So one was at Google I/O, maybe 2018, something like that. It was a big talk, like a big room. We had maybe 2,000 people. I don't even remember what it was presenting, but I remember it was just very visually impressive, intimidating, in fact. I also remember a large talk we did in Paris. That would have been at the end of 2019. But the moments I actually remember the most fondly was just like working together with the rest of the Keras team, being like basically locked in and trying to ship Keras 3. We went from just Keras 3 as a concept and writing the first lines of code and not really knowing if it was even feasible to make like the same framework that would run on top of libraries as different as PyTorch versus JAX, for instance. So it was really like a shot in the dark, effectively, and just like working our way to shipping. And the code base, the core of the code base was written in like about 2 months.
Yeah, a couple months.
So we were like really locked in, all working together. It was a really fun moment. Like, I was shipping like, I don't know, several thousands of lines of code per day.
Matt, when you said you've been at Google for quite some time, working on Keras in many different forms, what has been like kind of the particular aspects of Keras that you've been working on, involved in, leading over the years? Yeah.
I mean, I used Keras as a community member way back when, and then kind of a couple of years later saw the chance to go work on the team and was excited about it, loved working in open source and loved Keras. So it was a pretty obvious fit. The first thing I was working on was actually like pre-processing layers. We were adding some like text and image kind of pre-processing and just general kind of like feature extraction layers. So I was working on that. And then what I've been working on for the most of my time at Keras is, obviously last 4 or 5 whatever years is kind of the advent of these really large pre-trained models that most users are not going to be able to churn out themselves, but will add a lot of performance to your system. So yeah, I think some of that was actually François did some of the first of this in the whole industry with Keras applications, which is kind of putting out some vision models or whatever. But for most of my time, I've been working on Keras NLP, Keras CV, which we have finally kind of coalesced into a better kind of single version KerasHub for kind of accessing pre-trained large language models, vision generation, like stable diffusion type models. So that's been, I'd say like 80% of my work on Keras has kind of been setting up the pre-trained modeling libraries for Keras and Keras 3 now.
The relevance of pre-trained models, I think, has also become much, much higher now, right? Like I remember back, when we had just visual models, like, you'd take some models, you'd fine tune image models and things like that, but people were training models from scratch on a much more regular basis. Whereas today, like taking a pre-trained model and then working with it is pretty much the de facto way of interacting with the industry.
Yeah, I think so. Keras CV and Keras NLP have been around for a while. They existed originally as more of these like kind of bags of tools for like doing tokenization and doing kind of some image manipulation and stuff. But I don't know, pretty quickly in the history of this, it became clear that the biggest thing that people want more than like a tokenization library is important, but the biggest thing that people want is, access to pre-trained vision and language models. And then, for the last few years, it's been clear that the line between vision and language models is getting blurrier and blurrier. And, you have like you have diffusion models and transformer models, but you have these like transfusion models, I think, where you got image in and image out to transformer flows. So it's kind of, that was why we knew we were focusing on pre-trained models, and it became clear it'd be a lot easier to stick that into one kind of pre-trained modeling package, which is what KerasHub is.
Awesome. And you talked about kind of feedback from the community and like figuring out what it was that people were doing and what people wanted. How does Keras, engage with the community and learn about what people are asking for, right? The Keras community has now grown to be quite a sizable number of people using it for what I imagine is a very wide variety of use cases. Yeah. Does Keras have like, do you all send out regular surveys, or or maybe you just talk with folks directly? But like, it's tough to scale, right? At a size.
No, it is tough to scale. Like so we've got like over 2 million users now. And yeah, so we do a regular survey, but that's not the most important part. No, I think just talking to users, like sitting down and looking at someone go through some workflow for the first time and just commenting what they're doing. This is actually so insightful. Keras is all about trying to optimize the UX of the framework, trying to minimize developer-facing cognitive load and so on. And of course, the only way you can do that is that you actually work closely with your users. And in fact, you should also be a user yourself, with a beginner mindset, and just like regularly use the framework.
GitHub's probably been the most consistent and major feedback signal always is, people opening bugs on things that don't work and people just being like, hey, I really need this feature and I'm going to submit a PR to add it or whatever. Most of my work on the Keras team is just directly on the issues list and pull requests and what. GitHub is where I do all of my work, and so that means there's not too much of a distinction a lot of the times between people that are just contributing from the community and people working on it at Google.
We've had lots of features that are just contributed by the community, people opening a PR for the first time, and then we work with them, and then the next PR from them, arrives, and then the next and the next. Also, we have a bi-monthly community meeting online, which is basically a Google Meet call. Anyone is free to join, and so we get a bunch of people in there, community members, and we present, here are the latest features, and we just discuss with folks, we take questions and so on.
Awesome. And so if folks who are watching or listening to this want to find out more about that bi-monthly call, where can they get the link or the invite to join that call?
Currently, we're about to be pushing a new version of the Keras.io site. Right at the bottom of the page, there'll be links to kind of all of our community stuff, including just a add this to your calendar link for the community meeting.
You've always focused on the usability, right? The developer experience or the UX of the library. Can you talk a little bit more about that process and how the design of the API over the course of a decade has changed? Keras has gone through so many iterations over the years and has had to make these tough decisions. So we'd really love to get some insight from both of you on what that process was like in terms of balancing those trade-offs of doing what's right from a perspective of design, but also doing right by your community, by your users, so that they can have the consistency and usability that they expect.
Usability was always the core focus of Keras. I started it when all the available machine learning frameworks were super hard to use. You had Theano, for instance, or frameworks that were just based on specifying models via YAML config files like Café or Pylon and so on. And Keras was basically the result of asking, okay, what if we made it as easy to use as scikit-learn? One of the big insights with Keras is that the model is defined via code, not via YAML file like it was the case in all the deep learning frameworks in early 2015. And over the years, usability was probably the number one reason why people got into the Keras ecosystem, and so it really stayed as this core focus of the library. And the main design principle behind the API is progressive disclosure of complexity, which is this idea that simple common workflows should be super easy. So anything that most people are going to want to do should be just a couple lines of code effectively. And anything that is very complex, very advanced should be possible. And it should be possible through a path that is incremental. And there should not be a cliff where we're like, okay, until now it was easy, but now I need to customize this thing, so I have to throw away this entire pile of code and rewrite it from scratch. We don't have that. Instead, it's like, okay, I'm gonna, take this component, open up the box, customize it, put it back.
The kind of functional model, the basic confile and fit APIs have actually been remarkably static over 8+ years or whatever, which I don't think there's any other library that could say something like that. And if you look at there's so many different libraries in Torch, JAX, and TensorFlow ecosystems that have kind of picked up on the kind of API design patterns of layers of compile, of good names for like convnet args and stuff like that, that you can truly see Keras's like API kind of influence like all over so many libraries in the ML ecosystem. But I think we've had kind of like ergonomics of code as a design principle from the start, which means that, you know, the APIs can actually hold up over 8 years and many different versions and many different backends, which is pretty cool.
Keras is actually the oldest framework that's still widely used today. Like all the frameworks that existed.
I was just thinking that. I was like, wait, Keras started before TensorFlow. Theano is no longer in use. PyTorch and JAX came along later, but Keras has the single through line across all of those libraries. Like you said, you started with language models, and then it turned into vision models, and then some other stuff happened, and now we're doing LLMs.
Yeah, and now it's like Java 3 and large-scale distributed training of LLMs. Yeah, I mean, one of the key to that longevity is the ability to adapt. Like there's some change in the industry, like, oh, TensorFlow gets released. Now the problem is just going to support it, you know, and so on and so on. Or like, oh, now you know, it's all about stable diffusion and LLMs. Now the problem with KerasHub and so on.
Yeah, I think one of the, in terms of progressive disclosure of complexity, Keras 3 makes it, it's just very cool that you can kind of go down the levels of abstraction of Keras and modify things more and more and do custom layers and custom training loops. But now you can go all the way to, if you do want to use JAX and you're doing something really large scale, you can set your backend to JAX and go all the way to writing custom JAX code or writing custom JAX kernels, or similarly for PyTorch. It just gives you this like extra layer to jump down to like native backend code.
For any software product, sometimes they'll have all sorts of guides and tutorials, right? And sometimes the getting started or the quick start materials can be quite lengthy and really make it very challenging for someone new to a library or an API or any software product to get started, because it's like, okay, if I'm going to start using this, I need to know all of these things and do all of these steps in order just to begin using it. If this is the beginning, what's after that? Like, do I even want to find out? So it's really cool that you have that set up.
Simple things should be easy. Simple things should stay simple.
I think
advanced things, advanced workflows should be possible, and the path to get there should be incremental and very tractable. So it should kind of follow the level of complexity of your code base, should follow your own level of expertise effectively, and the framework, the tooling should guide you on that path.
But you know, like we're working on Gemma 3 stuff right now, and kind of the first thing I come to is like, all right, what's 20 lines of code we could show to a user that like will hit a main workflow and just like not suck. Like you want to look at it and be proud of that 20-line kind of quick start that you can go from, and then you kind of layer on top of that, all right, how are people going to customize this? What are the kind of more complex workflows that we need to cover?
In terms of like, when I think about the tools and libraries that this community, and I mean like broader than Keras, but just the ML community at large, really like, what is it that people love? The other one that comes to mind is Kaggle, right? In terms of a community of users that are kind of like-minded and are very, I don't know, they're very responsive users, you know? They share feedback, they're supportive of each other.
They're very user-centric.
They're all just there, yeah, they're very just there to learn and grow. And I know like Keras has had some collaborations with Kaggle over the years.
Yeah, before starting Keras, actually, I was active on Kaggle. Kaggle was actually one of the my first opportunities to apply deep learning on real problems. And part of how Keras got traction in the early days was through Kaggle. Like Kaggle in general has been great at surfacing and popularizing new best practices, and Keras was one of them.
Pre-trained modeling workflows are becoming such a dominant part of ML workflows overall. And yeah, Kaggle has this very similar kind of user focus ethos to Keras, I think, in a lot of ways. So yeah, recently Kaggle Models has become a thing, which is just a kind of platform for people to share. It doesn't have to be Keras models, but kind of any models, pre-trained models that you want to share or fine-tune and share with the community. And Keras, through KerasHub, we've integrated, so all of our models are hosted on Kaggle. You don't have to use them through Kaggle notebooks, though certainly you can. You can use it in any in Colab or in your own scripting and download it. But then also, if you do want to use it in Kaggle notebooks or in Kaggle competitions, they're right there, and you don't have to download them in some lengthy step. It makes it really easy to just like go into a competition and choose a pre-trained model or a set of pre-trained models that you're going to use to kind of get to good performance on things and just start running with it very fast. So it's a great fit for Keras. The other thing, you don't just want the code for running these pre-trained models. The main currency of all this stuff is the weights itself. So Kaggle models is where KerasHub will store all of our pre-trained model weights. So yeah, you can go, if you go on Kaggle, I think there's a kind of modeling side on the sidebar. You can search, there's tons of different publishers publishing models, but you can find models to use there, among them being these KerasHub models.
So KerasHub is the Python library with all the models, and Kaggle models is the model store. It's where you have the weights to download.
You want to be able to take a pre-trained model, do some fine tuning, make an interesting classifier, share that out with people. So to do that, you need a platform where you can have models, you can have like comments on models, notebooks attached to models, share out a link to the thing that you just made, get other people to use it. So that's what Kaggle in a big way has been for us, kind of the sharing platform and community platform for doing pre-trained modeling stuff.
And something I'm also just realizing now as we're talking about this is that, like Keras, Kaggle has also been around forever, right?
Kaggle has had a huge influence on the machine learning world. And it's sort of like flying under the radar, but it's been hugely influential. And yet it's been around since forever. And Kaggle was actually the place where many of the most important developments in machine learning got surfaced and became popular. I'm thinking in particular the idea of using gradient boosted trees for structured data and the XGBoost library that actually started on Kaggle in the Higgs boson competition in the summer of 2014. I was actually doing that competition back in the summer of 2014. I was using a combination of deep neural nets and, of course, things like random forest, gradient boosted trees, and so on. So I sort of like added XGBoost to my ensemble as it came out. This is really like the competition that put gradient boosted trees on the map. So I ended up doing fourth place in that competition, which was very disappointing because you only get a prize if you're in the top
close.
three. And a year later, like Keras was a big thing, and everybody started using Keras and Kaggle. It's like around 2018, 2019. Keras was like by far the most used library for things like vision and so on Kaggle.
Yeah, I mean, I think if you're trying to start learning machine learning in general as a field, it's just a very grounded place to start as Kaggle competitions. There's a lot of hype around a lot of different things, but if you go try to like do well in a Kaggle competition, you're going to pretty quickly figure out what people are actually using and what actually works.
Yeah, that's also just a great tip for kind of, like you said, folks who are learning, folks who are coming up, and the next generation of machine learning engineers and AI engineers and whatever the new titles that will come along in the years to come. Go to Kaggle, check it out, use Keras, and find out how these libraries are being used in real world competitions where there are real stakes. I wanted to also do some fun questions with you all. I think the community would love to learn a little bit more about yourselves as people, as engineers. The classic questions we have to, of course, cover are things like, firstly, tabs or spaces.
Spaces.
Definitely. It's obviously spaces.
Spaces on both sides.
Yeah. That's not the discussion. Yeah.
And then the other classic one, of course, is around text editors, coding IDEs, Vim, Emacs, neither, both.
Yeah, I used to use Sublime Text a lot. Like Keras was originally written in Sublime Text and was developed in Sublime Text for quite a few years. Lately, I've actually switched to VS Code, so that's my daily driver code editor. It's VS Code.
Yeah, for me, Emacs was the start of this. Like back in high school, college days, want a, really simple editor you can use anywhere and will be installed on every Linux machine. But then, yeah, Sublime Text after that got addicted to multiple cursors. They should be everywhere, and then VS Code through that, I think, is the rough story.
Do you have any kind of tips that you think you want to share with folks who are on their kind of machine learning educational journeys?
Focus on learning the concepts really well, honestly. Like if you find something and you can't really explain it or you don't know why, it's usually worth like peeling back a few layers and trying to get to the point where you actually understand what's going on under the hood for things. Where the newest version of deep learning with Python is going to be out soon. That is a great place to kind of get a really broad picture of kind of everything from the basics of deep learning to vision and text modeling, kind of, all the way up to generative modeling with stable diffusion and transformer style models, which shows everything through the Keras API. So good for Keras community as a place to start out.
So if you look at the history of deep learning and the machine learning community in general, there's always something new. Like every quarter, maybe every month, every week, there's always something new. There's always so much hype around everything, And this can be, very, very intimidating and confusing for people just getting started in the field. It feels overwhelming, It also feels like it's moving too fast. So it's not actually moving all that fast. The hype is moving very fast, but if you look at the lower layers, the models are not evolving that fast. The architectures have been very stable. The training techniques have been very stable, and the core concepts, like the theory, has been extremely stable over the past few years. So my advice would be keep learning, keep adapting as well. Like there's always going to be something new to jump on. So be aware of that. Watch out for it, but don't follow the hype. Don't believe the hype. Whenever something new comes out, evaluate it, on its own merits, like from first principles. Is this interesting based on what I know? Is it something I should try? Is it something I should adopt? And don't make these decisions just based on, is everyone talking about it? Because of course everyone's going to be talking about it, but that's not what makes it valuable, So adapt, but don't believe the hype.
Yeah, totally. I mean, I think, what's exploding today is like reinforcement learning, DeepSeek style, large language model stuff, but transformers have been around for so many years. Reinforcement, all of these techniques have been around for many, many years, and obviously a core part of the field and something anyone can learn.
And if an idea comes around that's actually new, you should pay attention to it, of course. And whether or not there's hype around it or no hype around it, just always evaluate new things on their own merits. From first principles, and this is the way to really be on top of things.
Well, thank you so much, Matt, François, for joining me today. It's been a huge honor to chat with you and learn more about Keras. Learn lots of, I think, historical tidbits and stories, and good advice and tips and learnings across the board. So as we celebrate 10 years of Keras, what do we have to look forward to 10 years from now, you think? Will Keras still be around, hopefully? And what's that going to look like when we're celebrating the 20th anniversary?
The landscape is going to be so changed in 10 years. So I think in particular, one domain of AI that I expect will be taking off is program synthesis and some form of fusion between deep learning and symbolic approaches. So symbolic approaches as in things like discrete program search, trying to learn your own symbolic programming language autonomously and so on. We'll see. Hopefully there will be a Keras. So hopefully there will be a Keras for program synthesis in the future, and maybe it will be Keras.
Just in terms of like the universality of kind of like the basic Keras core examples of like put a bunch of dense layers together into a simple neural network and train some stuff and compile a program and compiling your graph to better optimize it for the hardware. Like all the basic abstractions, things layer on top of it. But the stuff that's in Keras today, I think it's still going to apply 10 years from now, just with a lot of new things added on top.
Deep learning will still be useful in 10 years, that's for sure.
Yeah.
Thanks so much, Francois and Matt, for chatting with me today. It's been absolutely delightful, and I'm excited to see what the next 10 years of Keras brings.
Thanks so much for having us.
Thanks.